Question 3. This question is about enthalpy changes. When ethanoic acid reacts with sodium hydroxide, the enthalpy change delta H is minus 56.1 kilojoules per mole. I've been given an equation, ethanoic acid and sodium hydroxide. Calculate the temperature rise, 25 centimeter cubed of 2 mole per decimeter cubed ethanoic acid. I'm not going to read any further than that. I've got a volume and I've got a concentration. So concentration equals moles divided by volume. So I've got a volume and I've got a concentration. So concentration equals moles divided by volume. Therefore, moles equals concentration multiplied by volume. So moles is concentration multiplied by volume. There's my concentration 2. My volume's in 25 centimeter cubed. It needs to be in decimeter cubed. Centimeter cubed into decimeter cubed, smaller into larger units, so divide by 1,000. And it works out as 25 divided by 1,000, or 0.025 multiplied by 2, will give me the number of moles of ethanoic acid that I have. Okay? It reacts with the same number of moles of aqueous sodium hydroxide, 25 centimeters cubed, 2 moles of that sodium hydroxide, 1:1 ratio. Okay. Assume that both solutions have the same initial temperature, have a density of this specific heat capacity. So what have I got? Specific heat capacity, it must mean that I'm using Q equals delta H equals MC delta T. I must be doing that because that's the only one with specific heat capacity C in. So first of all, what am I going to find out? I need to find Q or delta H for this reaction. Well, it tells me that minus 56.1 kilojoules of energy are released, minus 56, when I have reacted a mole. Except that I haven't reacted a mole, I've only got 0.05 moles. So if 1 mole gives out 56.1 kilojoules of energy, then 0.05 multiplied by 0.05, it'll come out as 2.805 kilojoules, or 2,805 joules. Multiplied by 1,000, get into the smaller unit of joules. 2,805 joules of energy for 0.05 moles that I have. So look at what I did again. I worked out the number of moles that I have. This is for 1 mole, multiplied by this smaller number of moles, multiplied the enthalpy change for 1 mole by this smaller amount of moles, and I've worked out the number of kilojoules of energy that are released, and I've put it into joules, because in this equation here, delta H needs to be, or Q needs to be in joules. So 2,805 equals MC delta T. What's the mass of the liquid that I've got? Well, I've got 25 centimeters cubed of each. That's 50 centimeters cubed. Assuming a density of 1 gram for every centimeter cubed, I've got 50 centimeters cubed, or 50 grams. So my mass is 50 grams. C is 4.18, specific heat capacity. Delta T, I don't know. I've multiplied out the 50 by the 4.18, so 2,805 equals 209 multiplied by delta T. Delta T is 2,805 divided by 209, 13.4. Everything here seems to be to 3 significant figures, 4.18, 3 significant figures. I'm going to keep it as 3 significant figures, 13.4. I've plotted some points on the graph here, and I've extrapolated to time 4, because it says that I'm measuring the temperature in a polystyrene cup during this reaction, and on the 4th minute I've got ethanoic acid in a cup, and in the 4th minute I've added some sodium hydrogen carbonate. I can't measure the temperature at the 4th minute, that's why I haven't got a reading, but I've got readings for the others that have been plotted on the curve on the point here. But I need to find out what temperature it is at time 4 by extrapolating forwards and extrapolating backwards. Now this, I ignore that point, because the reason it's not dropped straight down to here and then come back up is because that the thermometer can't respond that quickly. But it will drop down here to about here and then start rising up. I need a line of best fit. Remember, a line of best fit can be a curve. A line of best fit on this, forming a curve and extrapolating back to to time 4. I think it's going to work out 11.2. There we go, I've plotted it onto the graph now. It comes out at about 11.2. So I've got 17.2 and 11.2, so the temperature change is around about 6.0. So about 6.0, I'm allowed on my mark scheme 0.2 either way out, so I'm allowed 5.8 up to 6.2.